Hello and welcome to Today in Space, the all things space science podcast, where we explore the latest and most intriguing developments in space exploration. I'm your space science podcast host from the East Coast, Alex Giorfanos. I'm down on mission most of February here with the flu, whatever the hell I caught, but space progress continued and we stayed watching. One of the most interesting and unique missions to follow along with was JAXA's all-wooden CubeSat, LignoSat. Now, what is Japan's space agency doing sending a wooden satellite into space from the International Space Station? Why is wood a great space material, apparently? And could wood be better for the environment than metal? And what applications for space travel can wood help with in the future? No more questions, let's dive in. To start, let's get down to basics. What is the LignoSat mission? Well, JAXA's LignoSat is a wooden CubeSat or a microsatellite, smaller than your head, that can easily be packaged and launched. They become commonplace in today's world, and I actually worked on a CubeSat project when I was in college. They are a great way to learn and access space. They can either be launched from rockets or from the P-Pod unit on the ISS, which I think is the name of it still, but that's what it was back when I was doing my research project. But it's basically a springboard launcher that sends these out into space. And that's exactly what happened with Kyoto University's LignoSat on December 13th, 2024, when it was deployed with 2 other satellites. The mission intends to showcase wood in the harshness of space as a structural replacement for metal structures typically used for things like this. And this mission is actually a continuation of research done on the space station by Kyoto University. Various wood samples were tested and exposed to space for 10 months to see how it reacted to radiation, the vacuum of space, extreme heat, cold, and more. Wood performed so well that Kyoto University continued their research and built a CubeSat. Let's pause for a quick break here before we get to section 2 to acknowledge the fact that there is a lot of change in the air in the space industry right now. Between NASA and Blue Origin, there are a lot of people without jobs at the moment or between jobs. And that's not to mention plenty of other companies, big manufacturers of aerospace that have made cuts in the last month since the start of the year. If you're a space professional, you're listening to this podcast, we like to offer to come on the podcast to talk about your STEM origin story, what it was like working for those companies, and what you're looking to do next. Our door is open. Introduce yourself to the Today in Space Network and to the internet. It's a great way to put yourself out there, especially if you're on the resume job searching hunt. Email us at todayinspacepodcast@gmail.com. We would love to make a connection with you and to help promote what you're doing and just the awesomeness that you've worked in the space industry. People want to hear about that. If you want to get your story out there and get a great digital interview for your resume or to promote whatever you're up to next, hit us up. Great change can turn into great things, and we'd love to help you in this dark time. Promote yourself and get the great work you do out there. So email us todayinspacepodcast@gmail.com and let us know if you want to come on the podcast and talk about all things space. Now let's get back to the episode. Why wood makes a great space material. So what did they find from their research on the station that gave them the confidence to move forward with building a CubeSat to launch into space? Well, wood has surprisingly unique properties for space. It has natural thermal insulation properties, has a great strength to weight ratio, and can be sustainably sourced. Most wonder materials like aluminum and titanium are great strength to weight ratios, but they are certainly not sustainable materials. Not to mention, they do not have great thermal insulation properties, which requires more mass added to the space object and complexity managing the thermal fluctuations in a CubeSat. I know one of the revelations of working on a CubeSat project was the hot or the in-light and shadow side of a small 3U CubeSat, which would be 3 of these LignoSats stacked up against each other. The flex and the thermal distortion that would happen because one side space is a vacuum. You have one side getting all of the sun's energy and heating up very hot, the backside being in a vacuum, completely cold without any light. So you have these extreme temperatures on either side of the spacecraft, and you have to account for all of that. Otherwise, your spacecraft isn't going to last long and could actually start tumbling out of control. I mean, that's part of what makes these asteroids and comets change their orbit over time, is their effect against the sun, right? The same thing can happen on a CubeSat. I just thought that was fascinating. It was not obvious before I learned it. So anyways, if wood can be used in a way that can help reduce that just by its natural properties, I mean, that's material science gold and would be a welcome addition to a spacecraft. Another aspect that makes wood a great space material is with orbital debris and environmental impacts of re-entry. One of the major downsides of these wonder materials is that they have a very high melting temperature. This means that re-entering the atmosphere doesn't guarantee that all the debris actually burns up. And there have been enough orbital debris incidents of space junk going through people's ceilings to make it a problem worth solving. Wood would allow a spacecraft the strength and durability to get to space, survive the environment of space, and then also fully burn up in the atmosphere, reducing the chance that anyone could be impacted on the ground or whatever it's doing to our atmosphere. Wood for safer re-entry and reduced orbital debris. Orbital debris has been a risk, continues to be a risk, and will become more of a risk with more and more things going into space. That's just the reality of the world we're in. We've seen International Space Station batteries from NASA go through someone's ceiling. Defunct satellite like Starlink and others deorbit on a regular basis because they're not functioning anymore. Maybe a solar flare took them out, something happened on launch. It happens. So they send them back into the atmosphere. Starship had its orbital debris issue on its last test flight, and that's not to mention China just free-falling launch debris over their people after a launch. There's a real need to change and to get some innovation here because it's going to get out of control if we don't focus on it. And we talked about some of the reasons wood could make a good material in the harshness of space, and it seems that it could also be better for our own atmosphere. So, the satellite and spacecraft of today that are re-entering the atmosphere are built with robust metals and composites. It makes sense. You need that to get to space. But aside from the atmospheric release of chemicals from these items, not even just the metal, but everything, all the wire, electronics, burning up in the atmosphere, there's also the concern of metallic dust from these robust materials that can litter the upper atmosphere. With no slowing down of launches or orbital debris in the future, the momentum is clearly going to get more and more. That means there's going to be more and more metallic dust in the upper atmosphere. And according to some research, if it's not taken seriously, the more progress in space would mean less progress for the climate. So what do? Do we just stop going to space? Or do we look deeper for new ideas and solutions we never had the motivation to look for before? That's what the Kyoto University and Japanese wood processing company Sumitomo Forestry team were thinking. First, as a huge space geek myself, this is fucking incredible. Space materials are so expensive, which then makes going to space expensive. Part of the expense is needing these robust and exotic alloys to get machined, casted, or formed into the shapes that they need to be for these structures. But they don't play nice with tools, the environment, or the machines trying to change them. But they work. Machining titanium, for example, which is rarer because it's so expensive, but it's dangerous and difficult. Cutters break, it can catch fire, it's reactive. Not to mention aluminum, which is much cheaper, but it's not that much easier to work either. But if a nation or company could grow its own space materials and have a shot at sustainability at the same time, that would be revolutionary. So let's break it down. Not only could wood in space applications reduce the cost of space materials in a sustainable way, but its properties have already shown promise that it's rugged against the harshness of the environment of space. And then on top of it, it could also potentially reduce the environmental effects of increased orbital activity on Earth by replacing metal. This mission doesn't get the love that it deserves. But we're spreading the word because in another 4 or so months, the LignoSat mission will finish up after the CubeSat is tugged back into the atmosphere by gravity for a burn-up on re-entry. If LignoSat survives throughout its mission and gathers good data, then we might see more eco-friendly space materials out there, sciencing the shit out of the environmental impacts that space travel can have. But also, it's amazing that we didn't think of wood in space sooner. I mean, Groot is a space wood alien. The writing was on the wall the whole time. But we're just really glad that this mission, LignoSat, is happening. We love CubeSats. I mean, that's what got me into space. It was literally, we were working on a Cube satellite for solar weather, and I wish every aerospace engineer had the opportunity to work on a CubeSat. For us, we actually never got to launch a mission to space, so the Kyoto University team is crushing it, and I love to see that partnership of the forestry team and the university students trying to take this material science approach. So, very cool mission. We love seeing it, and it'll be interesting to see what this magnolia wood, like, is it a special kind of wood? Is it only grown in Japan? And I definitely want to dig more into all the individual types of wood that they chose and how they each handled the space environment. But we'd love to know what you think. This is Today in Space. Follow us along online, Today in Space on TikTok, Today in Space Pod on Instagram and Twitter, Today in Space Podcast on our Facebook page, and you can always email us at todayinspacepodcast@gmail.com. We've been playing around with the idea of having a phone line so that people can call, leave their questions, and we could do a show just doing questions, go live. Let us know what you think about that, and if you're interested. And don't forget to check out our 3D printing lab, AG 3D Printing. We're doing a ton of new stuff. We just put out a new blog about a smart 3D printed business card in multicolor that we embedded an NFC chip inside. So we tried to tackle the problem of the business card and seeing if we could make it better. So go to ag3d-printing.com. Go to the Part Detective case files that's right at the top in the menu, and check out our blog post, One Business Card to Rule Them All. We had a lot of fun with that. We're trying to do some more content on the 3D printing side. You can follow our work at AG3D Printing on Instagram and AG3D Printing Lab on TikTok. We're also out there on LinkedIn as well. Have a great day, everybody. Thank you for joining us. This has been Today in Space. Spread love and spread science. And stay focused out there. Be well.